Unit 6, Exploring Quadrilaterals, Section 6.1, Quadrilaterals and Parallelograms. Our objective is students will successfully recognize and apply the properties of quadrilateral and parallelograms. So at first, we should define quadrilateral. Quadrilateral is a four-sided polygon. So this is an example because there is 1, 2, 3, 4 sides. In order to name a quadrilateral, we use our vertices. So I am going to call this quadrilateral. And I start at a point and I go around. So A, B, C, D. You don't have to start at the lowest or the first in the alphabetical order. We could have also called this quadrilateral C, D, A, B. Okay. As long as we go around, we're okay. We cannot go through the middle of the quadrilateral. Interior sum of a quadrilateral. The sum of the interior angles of a quadrilateral is 360 degrees. To show that that is true, if I take triangle CDB and rotate it around its midpoint, I get triangle EBC, which is a quadrilateral. Now, when I rotate, that would mean that C here corresponds with B here. So this angle would be an 80 degrees. When I rotate, B here would correspond to C there. So that becomes 70 degrees. And this angle and E correspond, so that would be 30 degrees. If I take 30 plus 70 plus 80 plus 70 plus 80 plus 30, that would be all the interior angles. If I add those together, I get a total of 360 degrees. Alright, what we can do with that is I now have a quadrilateral, I have some expressions inside, we want to solve for x, and then we want to find the measure of angle k. So we add the interior angles, so 6x plus 3 plus 110 plus 5x minus 7 plus 11x minus 10, and set that equal to 360. Combine like terms, so 6x, 5x, 11x adds up to 22x. Our 3, our 110, our negative 7, and negative 10 are like terms, and those add up to 96. We are going to subtract 96 from both sides. We get 22x equals 264. We divide by 22, and we get x equals 12. Now we need to find the measure of angle k. So the measure of angle k was our 5x minus 7. So to find measure of angle k, we are going to plug in our 12 in for x. So 5 times 12 minus 7. Oh, that's off the screen, sorry. So 5 times 12 is 60. 60 minus 7 is 53. So the measure of angle k is 53 degrees. And x was 12. Our definition of a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So, in this picture, this is an example of a parallelogram. So, these two sides are parallel, these two sides are parallel. We call this parallelogram we use a little symbol, parallelogram, A, B, C, D. Again, starting at one corner and working our way around it. The parallelogram is the only quadrilateral that we use a symbol for. Our parallelogram sides theorem says a quadrilateral is a parallelogram if and only if the opposite sides are congruent. So, if we have parallelogram EFGH, then our opposite sides would be congruent. So if I start with side EF, the side opposite EF is GH, so EF and GH would have to be congruent. And the other set of sides that are opposite are EH and FG. So EH would have to also be congruent to FG. Parallelogram angles theorem. A quadrilateral is a parallelogram if and only if the opposite angles are congruent. So, if parallelogram JKLM, then our opposite angles are going to be congruent. So angle J is what I'm going to start with. Opposite of angle J is angle L. So angle J has to be congruent to angle L. Angle K has to be congruent to the angle opposite, which is angle M. So angle K has to also be congruent to angle M. Parallelogram consecutive angles theorem. So if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. And consecutive still means the same thing that it meant back in Unit 2. Consecutive means in a row. So if we have parallelogram NOPQ, then angle N, his consecutive angle is angle O. So angle N and angle O are supplementary. Now, angle O is also consecutive with another angle. So angle O and angle P are supplementary. Okay, P is consecutive with another angle also. So angle P and angle Q are also supplementary. And Q is supplementary with angle N. So in total, we have 4 pairs of consecutive angles. Our last property for parallelograms is the diagonals of a parallelogram bisect each other. So if this shape is a parallelogram, so if parallelogram RSTU, then this diagonal RT bisects the other diagonal. And the other diagonal is SU. And vice versa. So SU bisects diagonal RT. And bisect means cut in half. So we could go ahead and put marks on our picture to show that. So if RT bisects SU, that means SV and VU are congruent. And if SU bisects RT, that means RV and VT are congruent. Okay, there are two types of problems that can be, or many types of problems that can be done with these theorems. The first question we ask is, what special quadrilateral is this? And right now, the only special quadrilateral that we know of is a parallelogram. So our question really is right now, is it a parallelogram? But the reason why we're asking it this way is we're going to add 4 or 5 more shapes, and we want to make sure we have the right one so that we use the right property with this. So, this is a parallelogram. And we know it's a parallelogram because of these arrows. Now, we have to go back through the theorems we just went through. And what is marked, those are sides. And we have to think about our theorems, and it said that the opposite sides of a parallelogram are congruent. So, what does that mean about these two expressions? Well, those two expressions must be equal. So 7x plus 2 equals 3x plus 22. Move your x's to the same side. So minus 3x minus 3x. And we get 4x plus 2 equals 22. Subtract 2. We get 4x equals 20. Divide by 4. So x equals 5. So again, the parts that were labeled were sides. We knew the opposite sides of a parallelogram were congruent, which allowed us to set 7x plus 2 equal to 3x plus 22, and then we used our algebra to solve. So again, new problem, same questions. What special quadrilateral is this? And from our markings, we can see that it is a parallelogram. What are the parts labeled? So we have 120 and 9x minus 6. Those are opposite angles. And what do we know about the opposite angles of a parallelogram? They're congruent. So I'm going to take 120 and set it equal to 9x minus 6. I'm now going to solve that with algebra so I can get x. So add 6 to both sides. I get 126 equals 9x. Divide by 9. 126 divided by 9 is 14. So I get x equals 14. And again, I was able to create the equation because I knew opposite angles of a parallelogram are congruent. Okay. For some practice with proofs, we have parallelogram GEOM. We want to prove that angle G and angle M and angle O and angle E and angle G are all supplementary. So all that we get to start with is knowing that we have parallelogram GEOM. Okay. We want to prove, so we can write that in also, angle G and angle M and angle O and angle E and angle G are supplementary. So we are proving our consecutive angles theorem, our parallelogram consecutive angles theorem. So we can't use that theorem in this proof. Alright, so now we got to think about what we know about parallelograms. So it's a parallelogram, so its opposite sides are parallel. So GE is parallel to MO. We also know that GM is parallel to EO. So we're going to write that on the same line. So GM parallel to EO. We knew that opposite sides were parallel because we knew the definition of parallelogram. Now, if I knew I had parallel lines, GM would act as a transversal. So now I am looking at angle G and angle M. And if I think back to chapter 2, those are consecutive interior angles. And when we have parallel lines cut by a transversal, the consecutive interior angles are supplementary. That's our consecutive interior angles theorem. Double checking as we go around, I had parallel lines, a transversal. M and O are consecutive interior angles, so they are supplementary by our consecutive interior angles theorem. Two parallel lines cut by a transversal, consecutive interior angles are supplementary. So angle O and angle E are also supplementary by our consecutive interior angles theorem. And GE and MO are parallel with EO acting as the transversal. Oh, I already did that set, sorry. GM and EO are parallel with GE acting as the transversal. So angle E and angle G are consecutive interior angles, and by consecutive interior angles theorem, they are supplementary. So at the end of this section, you should be able to define a quadrilateral, define a parallelogram, and what are the properties of a parallelogram. So our definition of a quadrilateral is a four-sided polygon. Our definition of a parallelogram is quadrilateral with opposite sides that are parallel. Okay, what are the properties of a parallelogram? These are our theorems that we discussed. Opposite sides are parallel. Opposite sides are, I didn't write the word sides, sorry. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. You need to memorize these 5 properties. If you don't memorize these 5 properties, you are not going to be able to do problems such as this example or these examples. Okay? You have to memorize these 5 properties. And as we get more and more shapes, we are going to add or subtract properties depending on what shape we're talking about. So it's very crucial that you learn that a parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Homework is the parallelograms worksheet.